All right, pull out your pillow, guys, because this section is going to be so easy you can do it in your sleep. Not really, but it's not going to be as bad. Like I promised at the start of the day. First video, that was a doozy. But we got through it. Now we're getting the easier things. We're going to start with example 6. Find the average velocity. Ooh, velocity again. Find the average. Whoa, I skipped like three words. Find the approximate average velocity on the interval from 0 to 4 if the velocity at 0 is 1, the velocity at 1 and 2 are the same and equal to 2, and the velocity at 3 is equal to 3. No units have been provided here. How can we estimate the average velocity? Well, remember how we find averages of anything, right? If I got a 95 and a 97, my average is a 96. You just add them up and divide by 2. If the average is 2, 5, and 7, just add them up, divide by 3. In general, to find the average of something, just add them all up and divide by how many there are. Well, there's 1, 1. There are 2 2s. And there is 1, 3. There are 4 seconds total. That's going to be 8 over 4. Average is 2 units per units. Let's say we're talking about meters per second. So we started off going 1 meter per second, and then for 2 seconds we were going about 2 meters per second, and the third second we were going about 3 meters per second. Now I'm sure our velocity is smooth. Sure, we're not just like jerking, like going at a single pace and then immediately starting to run and stuff like that. But we're approximating, and this is a way to approximate. Let me rewrite this little guy. I'm going to rewrite this thing as quarter times 1 times 1 plus 2 times 2 plus 1 times 3. This should stir up some memories from the previous section. This is a Riemann sum. Okay? And specifically, it's actually a Riemann sum divided by the length of the interval, or multiplied by the reciprocal of the length of the interval. So 4 is the length of the interval. 1/4 is just going to be 1 divided by the length of the interval. The length of the interval is b minus a. And all this guy is just our Riemann sum. Just the area. So really, exactly in this problem, we're saying our velocity 1, 2, 3, 1, 2, 3, 4. In this problem, right, we're saying that we're starting off with this velocity, and then we jumped up to this velocity for 2 seconds, and then we were over here. Okay, where this is our velocity. And we found this area and divided it by the total length of the interval to find the average velocity. Right? Because the area of this first rectangle is just 1 times 1. The area of the second rectangle is just 2 times 2. The area of this third rectangle is just 3 times 1. And so if the velocity is simple, like this, we can find the average velocity is just the area divided by the length of the interval. Well, maybe the velocity is not so simple. Maybe the velocity was actually something like this. Well, then the average velocity becomes more complicated. We could approximate it better with more rectangles, or we could use the definite integral. Because area for positive functions is just the definite integral. Okay, so just like we did in this example, the average anything, just sum it all up and divide by how many things there are. Well, when we take things to infinity, this is what we get. Property, definition. I don't know if there's a definition or a property. You can call it whatever you'd like. If f is continuous on the interval from a to b, then we say f bar, or the book calls it f av, which frankly, I don't like. I think this is much more common, but, or even avg, but I'll try to be consistent with the book, is the average of this function. And it's 1 divided by b minus a, just like we had, times the area. What's the area? The integral from b minus a, or the integral from a to b of the function with respect to x. So that's how you find average values of functions. Just the area divided by the length of the interval. And we can see why with this little example, and then just take things to infinity, because that's what we do in calculus. Just take things to infinity. We'll be using this formula. We can write it like this to make it really nice. Just the area divided by the length. Okay, and there's some cool things to say about another way of seeing where that comes from, but keep things short. What the heck? In my notes, I have example 6 twice. Well, let's call this second example 6, example 7, shall we? Or let's call it example 22. That way, when you're reviewing your notes, you're going to wonder, did I miss a bunch of examples? This is great teaching. For anyone who's planning on being a teacher, confusing your students is a great technique. I don't know. Let's go. Suppose the velocity, it must be a great technique because I know a lot of my professors utilized it a lot in college. Suppose that the velocity after time t is given by t plus 1 on the interval from 0 to 5. Okay, and v of t is, let's do feet per second. The question is, find the average velocity. Well, we know the average velocity. The average velocity is 1 over b minus a, integral from a to b, of the velocity with respect to time. Now, normally these are x's, right? But just like derivatives, they don't have to be x's. It can be any variable we want. What matters is that this function, we can call this function whatever we want, v is fine, and that whatever our independent variable is the same as that. Because if those variables are different, we talk about that in Calc 3 or 4, depending on where you're taking it. But we're going to worry about just if the variables are the same. Okay? And now it's just fill in the blank. Well, a is 0, b is 5. What's the width of our interval? 5. Again, a is 0, b is 5, and our velocity function is t plus 1 with respect to t. This is just area. Let's visualize it. Okay. We go over here. And t plus 1 is just the line. Slope 1, y-intercept 1. We're going up to 5. So this is what our velocity function looks like. Well, the area, we can find that no problem. Oh, 5 is over here, guys. The area, careful, it's not a triangle. Haven't done a lot of this in this class yet. Not a triangle, actually. Right? It's a rectangle. plus a triangle. Triangle is 5 by 5. The rectangle is 5 by 1. The integral, just the rectangle, which is area 5, plus the triangle, which is 1/2 base times height. So we got 10 halves plus 25 halves. That's 35 halves. 35 halves over 5 is 7 halves, maybe? Let's check our answer. We didn't do this before. Let's check our answer. Before, we said the average velocity was 2. Does it look like this blue line is about the average? Yeah, I think so. There's the same amount of the function above it as below it. All right, I think that's the only one we did. Well, let's do it here. 7 halves, that's 3.5. Let's draw another line. 1, 2, 3.5. On this interval, is there about as much of the function above as below? Yeah. This triangle looks to have the same area as that triangle. So, looks like a good average value. Looks like we probably didn't make a mistake. Maybe we did. Can check our answer, but looks pretty solid to me. That's the whole section. All right, that's the average velocity if I remember to put units, because we never want to forget our units. We're going to lose a point for that. I don't want to lose a point. Average velocity is 3.5 feet per second. Whew. I almost lost a point. All right, let me know if you have any questions. We got more homework problems coming up for you in the next video, but this is all this section. Ow. I would not, another bonus lesson for all of you guys, I would not recommend slamming your hand into hard desks. That one's a freebie. Okay, good luck. Bye-bye.